Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x plus 3 to the power of x plus 2 to the power of x is equal to 5. Now what I'm first going to do is I'm going to factor out 3 to the power of x from our left-hand side. So now we have 3 to the power of x times 1 plus 1 plus 1. Now this is equal to 5. Now 1 plus 1 plus 1 is 3. So now we have 3 times 3 to the power of x is equal to 5. Now I'm going to divide both sides by 3. So now we have 3 to the power of x is equal to 5 over 3. Now I'm going to take the log of both sides. And whenever I have a logarithm in the form log a to the power of b, I can actually move our exponent here, b, to the front of the logarithm. And this is known as the power property of logarithms. So this would be equal to b times log a. So now we have, I'm actually going to move this x to the front. So now we have x times log 3 is equal to, now log of 5 over 3 is the same thing as log 5 minus log 3. So now I'm going to divide both sides by log 3. So then these two cancel out, these two cancel out, and I'm left with x is equal to log 5 minus 1. And log 5, is for log 3. So now the value of log 5 is equal to approximately 0.6990, and the value of log 3 is equal to 0.4771. So now if I plug these in, I get 0.6990 over 0.4771 minus 1. And this means that x is equal to, if we simplify this, this would be equal to 0.4651. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So I have x to the power of x is equal to x to the power of 2. Now, what I'm first going to do is I'm going to divide both sides by x to the power of x. So now I have x to the power of x divided by x to the power of x is equal to x squared divided by x to the power of x. Now, x to the power of x and x to the power of x, these two cancel out. So now I have 1 is equal to x squared divided by x to the power of x. Now, if we have something in the form a to the power of m divided by a to the power of n, then this is equal to a to the power of m minus n. And we are going to use this property for x to the power of 2 divided by x to the power of x. So this would be equal to, we can think of 2 as m and x as n, so this would be x to the power of 2 minus x. Now I'm going to ln both sides. So now I have ln of 1 is equal to ln of x to the power of 2 minus x. Now, an important property of logarithms is that, let's say we have ln of a to the power of b. Then we can actually move this exponent b to the front of the logarithm. So this would be equal to b times ln a. So that's exactly what I'm going to do with ln x to the power of 2 minus x. I'm going to move the exponent 2 minus x to the front of the logarithm. So now we have, well, first off, ln of 1 is 0. So we have 0 is equal to 2 minus x times ln x. Now this gives us two equations. We have 2 minus x is equal to 0, and we also have ln x is equal to 0. Now for 2 minus x is equal to 0, x is simply equal to 2. So that is one solution. And now for ln of x equals 0, we're actually going to take the power of e on both sides. So if I bring it over here, we have e to the power of ln x is equal to e to the power of 0. Now for e to the power of ln x, these two cancel out, so I simply have x is equal to e to the power of 0 is 1. So this is our second solution. So our two solutions are x equals 1 and x equals 2. And now let's go ahead and plug them into our equation. So if we first plug in 1, we get 1 to the power of 1 is equal to 1 squared. 1 to the power of 1 is 1. And 1 squared is also 1. So this is right. Now let's check x equals 2. We have 2 to the power of 2 is equal to 2 to the power of 2. 2 squared is 4. So we have 4 is equal to 4. And this is right as well. So our two solutions are x equals 1 and x equals 2.